Okay, so for this Chapter 2 test, we're going to have some material that goes back to Chapter 1, and that's always going to be true throughout the year. We're not going to ever just completely forget, hopefully, what we've covered in previous chapters. So here are some problems that you had on your Chapter 1 test, and they will be on your Chapter 2 as well. So this is one of those linear model problems. Just to kind of set up the problem, you can read through it, but we have this professor, interesting study he's doing. He's trying to make a connection basically between the number of hours spent playing video games and the cumulative GPA of his students. So here is some important information for us. For a student who plays video games 2 hours per week, the GPA is 3.24. For playing 5 hours a week, the GPA was 2.78. By the way, if you don't have a calculator, you might as well go and grab one. We're going to need it. If you need a calculator, let me know. So the thing to keep in mind with these word problems that involve you writing a linear model, that's just another way of saying write a linear equation. We should be really used to what a linear equation looks like in slope-intercept form. It's basically an exercise in trying to determine what the slope of this line is, and then we're going to work to try to find out what the y-intercept of this line would be. And the way we're going to come up with the slope is by using these numbers that are given to us, this information, and we're going to try to come up with a couple of ordered pairs. Because if I know 2 points on a line, I've got a formula that I can use to come up with the slope. Well, the trick is making sure that you set your ordered pairs up correctly. And to me, it really involves this part of the statement. What is it that this problem is asking us to determine? We are going to be predicting what? The grade point average. So if you're not sure about which of these numbers in the problem represent x coordinates or y coordinates, this always works. Whatever it is that the problem is asking you to do, you are to determine, in this case, the grade point average. Then everything in this problem that refers to grade point average will be a y coordinate. So you might just want to do this. Just go up to your problem and put a y above those numbers that talk about GPAs. Well, process of elimination, if we've identified the y coordinates, the other numbers that are in hours must be x's. So if it helps, you can label those numbers that talk about hours per week as an x. Well, now we have a couple of ordered pairs. With this phrase, I can come up with the ordered pair 2, 3.24. That's like a point on this line that we're coming up with the model for. There's another ordered pair. It comes from this phrase here at the end. X is 5, y is 2.78. Well, now we're in great shape. This is like a review problem because we know if we're going to write the equation, we've got to come up with the slope. Fortunately, we're professionals at using the slope formula, the change in the y's over the change in the x's. So grab your calculator and subtract your y's. It really doesn't matter which way you start with the y's, but do the same thing with the x's. So if you're going to do 3.24 minus 2.78, then you need to do 2 minus 5. So take a second, grab your calculator, and let's see what you get. I'll just do it this way. 2.78 minus 3.24. And we're going to divide that by 5 minus 2. And let's see if we can come up with a consensus of what that is. So who's got that? What do you got?
I got 0.15.
Okay, so we'll just round it off at 0.15. Who else got that? Okay, I see 1, 2. Got it? Okay. Got it? I'm trusting you because I actually don't remember. So, feel good about it? Got it? Question? Negative. Yeah, thank you. Thank you. All right, good catch. Okay, so we got the slope. So how do we find the b? If we know the slope of the line, then we can go to either one of these points, it doesn't matter which, to plug in for x and y. Really doesn't matter, I'm just going to go with the top one. So I'm going to plug into y, I'm going to use 3.24 equals the slope that we came up with times the x, which is 2, plus b. So we're going to be able to solve for b. So once again, you probably want your calculator. And I'm going to go ahead and erase so we know what the slope formula is. I'm going to erase this. So you got 3.24 equals, I guess that's negative 0.30 plus b. And now we're going to be adding 0.30 to both sides. And that looks like 3.54. Now, I want you to pay close attention to what I'm about to do because on the last test I had some people that they just kind of overlooked this part. And to me, this is the most important part of this problem. Give me the linear model. Okay? Give me the y equals mx plus b. Before you start doing anything with part B, tell me what the equation is. So the answer to part A, write a linear model, and we're going to use the variables G for GPA. So my linear model is going to be G, the GPA, will be determined by using this number for slope, negative 0.15, times a certain number of hours per week, which is h, plus this y-intercept of 3.54. Okay, that is my answer for part A. Any questions? Using the slope formula, y2 minus y1.
Yeah, every time I do that, I get 0.46.
Okay. Now in part B, we're going to use this model to make the prediction. All right. So it's basically just a matter of taking the number 12, and that represents the number of hours per week. We're going to drop 12 in for h and use our calculator to come up with the predicted GPA given 12 hours of playing. And the correlation here, of course, is more hours playing video games, theoretically, the lower the GPA. That's what he's trying to come up with. So using your calculator, let's come up with the predicted GPA. So when you get that, raise your hand. What do you got, Parker?
I got 1.74.
1.74. Does that look good? No, because this is bigger. Multiply those together. So we got our prediction, and that would be the answer for part B. So be deliberate. When it's asking for a linear model, give me that without plugging anything for h. Just give me the model, then show me how you use the model. Okay? And so we're done with number 1. Any questions? No questions? All right. Let's take a look at number 2. We have this manufacturer that sells packages of pencils and erasers. Our goal is to break this up into how much is a pencil, just one, and how much is an eraser. If they're sold in packages, we want to come up with just the price of a single. And this is going to involve a system. You know that because it tells you to set up a system of equations. Well, we need two equations. Basically, an equation to represent each of the prices of the packages. Okay? Well, I noticed that what I'm ultimately supposed to do is find the price of one eraser and one pencil. So I need a variable to represent what the answer is going to be. X, I'm going to let be the price of one eraser. So you notice how I let a variable represent the ultimate answer to the question. X will be the price of one eraser. Y will be the price of one pencil. And now I can look at these sentences that describe the packages. Okay, this package of 5 erasers and 2 pencils is 23 cents. Okay, so 5 times the price of one eraser plus 2 times the price of one pencil should be a total of 23 cents. That's one package. The other package is 7 erasers, so 7 times the price of one eraser plus 5 times the price of one pencil. That should total 41 cents. Well, now we're supposed to solve a system, so we have some options at this point. Give me an option for solving a system of two equations. Substitution. Elimination. We got another one out there. Graphing. Down the road, you're going to learn Kramer's rule. You'll have a fourth option. Well, right now, which one do you think would be the easiest? Okay, if we're going to eliminate, we got to pick a variable to eliminate. Which one? Want to eliminate y? All right, give me a process that I'm going to have to go through to eliminate y. Okay, could you do one of those as a negative? You could. So do you want to just go with 5 and 2? Okay, we'll go 5 and negative 2. So grab your calculator if you need it. And here is the top equation times 5. And 0.23 times 5. Okay. And now the bottom equation by negative 2. All the way across. And it's going to take addition. So a little reminder here, I'm going to be adding all the way across in order to eliminate y. So I'm going to get 11x, and then we need to subtract here. So what is that difference? 1.15 minus 0.82. Is it just 0.33? Okay, now divide by 11, and we're going to get the price of a single eraser, and that should be 3 cents, right? 0.03. So one eraser is 3 cents. This is in terms of dollars and cents. Well, now how do I find the price of a pencil? Plug it in. Does it matter where? Let's pick an equation. I'll just go with the top one. 5 times 0.03 plus 2y is equal to 0.23. See if you can take it from there. Use your calculator and see what you come up with for the price of a single pencil. $0.04. And so we have our final answer. So I'm going to be interested in, instead of on the last test, I gave you one of these and I said use elimination to solve. Well, I mean, that's okay, but it's a lot more exciting if I give you a real life situation and you have to come up with the system. That's what I'm interested in. Then you solve it. So make sure you understand how we came up with this system with 2 variables. Any questions on number 2? Okay, let's solve for the indicated variable. So this is going to involve PEMDAS in reverse. PEMDAS backwards. We're solving for x in number 3, so I always like to do this. Not many people do this, but because division into x also requires division into 3, I can't just divide into one and not the other. I'm going to think of x plus 3 as a group. They really cannot be disconnected. They have to be thought of together with the division. And why do I do that? Because now when I look at what's being done to x, I'm going to notice the division, because obviously we're dividing by t. But then instead of saying addition, I'm going to say parentheses. And now I'm going to make sure I get the right order. Because if I go in reverse order of PEMDAS, I'm going to take care of the division first. And how do I undo division? Okay, so I'm going to multiply both sides by t. And remember, if you multiply t times t squared, you get t cubed. And now we got a simple step that remains to solve for x. We undo adding 3 with subtracting 3. So my final answer here is x is t cubed minus 3. For number 4, we're solving for this variable called b sub 2. So there's a lot involved here. We have multiplication by a half, we have multiplication by h, and then we're going to deal with these parentheses. So how do we undo multiplication by a half? Please don't say divide by a half. No complex fractions. Yes? Thank you. You multiply by 2, the multiplicative inverse property. So that's going to be my first step, and I'll show it like this. 2a is now equal to h times this quantity. Okay? Still looking at PEMDAS in reverse. I've still got this multiplication, so I need to undo multiplication. In this case, it's okay to do division. I undo multiplication by h with division by h. And at this point, I no longer need the parentheses because I'm not multiplying this whole quantity by anything. Okay, so I'm solving for b sub 2. Well, how do I undo adding b sub 1? I subtract it. So that gets us to our final answer. So any questions? Just a review of how to solve for any variable. This is going to be so important for you heading to science classes. You really need this skill. Any questions? All right, we got one more. So now we'll take a look at this 3-variable system problem. And the idea here, as you can tell, the ultimate question that is to be answered is how much did the company invest in each of 3 different funds? And as you can tell at the beginning of this problem, the total amount invested split up among those 3 funds is $50,000. So if you go to the question, that will lead you to how to set up your variables. The question, how much did the company invest in each fund? Well, there's 3 different funds, so we need a variable to represent the investment in each. So I'm just going to do x is going to represent the amount invested in the growth fund. We'll just say GF. Y will be the amount invested in the income fund. And Z is going to be the amount invested in the money market fund. And once you have your variables established, then you just look at these sentences and they will guide you into what equations need to be written. And just keep in mind that since we have 3 variables, then we need 3 different equations to represent what we're being told in this paragraph. So I'll just number them as we go. This first sentence gives us an indication for our first equation. It says a company invested $50,000 in 3 funds. So if we take the amount invested in growth, we take the amount invested in income, we take the amount invested in the money market, and we add those up, we get a total of $50,000 according to that first sentence. Okay, now the next sentence will give us information about another equation. This sentence is talking about the rate of return. The whole idea behind investing money is so that we can get our investment back and then more. And that amount of money over and above what we invested, we call that interest. And so this gives us information about how much interest we're going to make off of each fund and then how much we made in total. So the way I write this next equation is I show 12% return, or I'm going to make 12% interest money on the amount that was invested in growth, and 12% as a decimal is 0.12. So this is how I show how much I made in interest off of that growth fund investment. And then I do the same thing with the income fund investment. I'm told that I earned 8%, that's 0.08. as a decimal. And then I do the same thing for the money market fund. I earned 5%, 0.05. And the total of those interest earnings should be $4,500, according to the problem. Now at this point, now you've got a calculator that you can use. It's going to do all the heavy math, but you might want to consider, some people don't like to deal with decimals, and it's easy enough to take care of that if you just think of multiplying both sides of this equation by 100. Or, in other words, we're just going to slide the decimal for each part of this 2 places to the right. Don't forget to do the same thing to the number on the right side of the equation. So if you want to not deal with decimals, this equation becomes 12x plus 8y plus 5z, and then the number on the right side would be, just think 4,500 times 100, so you have 450,000. So since we're not going to deal with this decimal form equation any longer, I'm just going to mark that out. And then we have one more equation, and it comes from this sentence here. I'll just put parentheses around it. The company invested twice as much in the income fund as in the money market fund. So the income fund, in other words, just think of it this way, the income fund should equal 2 times the money market fund. Okay? So when you set your equation up using our variables, you can kind of use this as a model. So the income fund, according to our variables, that's what Y represents. And then the money market fund is the variable Z. Okay? Now some people miss this problem because of this last equation. So let me just kind of give you a tip on what you can do to make sure that you set this up correctly. And you can do this with just any number you want to pick, just to test and make sure that the way you have this written is actually right. Just take a number to plug in for Z. Something easy. Let's just temporarily let Z be 10. You can do anything you want, but 10's easy. 2 times 10 then would be 20. If Z is 10, Y is 20. Remember that Z represents the money market and Y represents the income fund. Well, when we do our little test of letting Z be 10, does it match up with the way the sentence is worded? Is the income fund amount the same as doubling the money market? Okay? In other words, the income fund should be twice as much, and it is. So before I go any further, some people would miss this because they might switch Y and Z, but if you do a little test, then you can have some assurance that you've set it up correctly. Well, when we solve these systems of 3 variables, we have 2 options. We could use elimination or we could use substitution. I think it sets up better for substitution because Y is equal to 2Z, then we're going to replace the Y's in the other 2 equations with 2Z. And so that's what I'll show in the next step. So the first equation becomes X plus, and then instead of Y, I'm going to put 2Z, and then the plus Z equals 50,000. And now combine like terms to simplify this, and you get X plus 3Z is 50,000. All right, so we've taken care of the top equation. Now let's do the same thing with the middle equation, replacing y with 2z. We get 12x, and we can just go ahead and do this mentally. 8 times 2z is 16z plus 5z, and that equals 450,000. And combine like terms, and you get 12x plus 21z is 450,000. Okay, so at this point, we're going to turn to elimination. So we're going to put these two equations together, and I'll do that on the next slide. These two equations that have two variables each, and we're going to decide to eliminate one of the variables. So we'll just pick this up on the next slide. X plus 3z is equal to 50,000. And the other equation is 12x plus 21z is 450,000. Okay, and really there's no easier way. You could eliminate x or z. There's really no advantage to choosing one over the other. I'm just going to, I think I'm going to eliminate z by multiplying the top equation by -7 to force these to become opposite terms. So when I multiply by -7 on the top, I get -7x minus 21z. And if you multiply by -7, you get -350,000. And we didn't have to do anything to the bottom equation. 12x plus 21z is 450,000. And so to eliminate z, we're going to add all the way across. I get 5x. The z's eliminate, and this is going to be 100,000. So when I solve for x, I get 20,000. Okay, and going back to the way we set up our variables, x represents the amount invested in the growth fund, so I have that answer. I'm just going to write $20,000 was invested in the growth fund. All right, so now it should be easy enough to find the others. I can find z pretty quickly by replacing x with $20,000. I could have done that in either of these equations. Okay, subtract 20,000 from both sides, and I got z as 10,000. Okay, z represents the amount invested in the money market, so we've got that amount, $10,000. And now it's pretty easy using this original bottom equation, y is equal to 2z. Now that I know what z is, I'm going to replace z with 10,000, and you see that y would be 20,000. So that ends up being our final answer. We invested 20,000 in the growth fund, 20,000 in the income fund, and 10,000 in the money market fund. So I hope that helps. Hopefully you will go back and practice these. This is the Chapter 1 review material that will appear on the Chapter 2 test. So if you have any questions about any of these, send me an email or come and see me in academic support.